Okay, so did you guys figure out what it was I was doing to create this sequence? What's Mr. Short adding here? 7, right. So we say, what we do is we call this an arithmetic sequence. Okay, so that's what goes in the blank there on the board. Arithmetic sequence, and it has a common difference of 7. That's just what we call it. Common difference of 7. Mathematically, we write d equals 7. D equals 7. So that's just because 12 minus 5. Right. Okay, now, how do you find the next 3 terms? You just keep adding 7s. So hopefully, you continued my list. It's 19, 26, 33. How many have that right? A few of you. Okay. How do you find the nth term? So here's what you do. You say, look, I'm taking the negative 2 at the start here, and I'm adding on a bunch of 7s. How many 7s? Well, it depends on which term you want. So let's say you want to find the second term, you'll add 7 once. If you want to find the third term, you'll add 7 twice. If you want to find the fifth term, you'll add 7 4 times. See? So you're going to be adding that 7 n minus 1 times. So the general term is actually this. The next 3 terms were 19, 26, and 33. In general, the term would be negative 2 plus a bunch of 7s. And there's other ways to write it. What are you going to ask?
For the general term, can you distribute out the 7 and then 0?
Sure. So what did you get when you did that?
7n minus 9.
Yeah, 7n minus 9 is a valid answer also. Yeah, good. Okay, let's look at the next one. The first 2 terms of a sequence, arithmetic sequence, are 4 and 7. Find the 20th term. So if you want the 20th term, I guess you could add 3, 3, 3, keep adding it, but that would kind of take a while, and that's probably not the best way. So what you probably want to do is create a formula, and then you can find the 20th term. So according to this, the 20th term should be the first term plus 19 common differences. So the first term is 4, and you're going to be adding basically 57. So 61 is the right answer. Did anyone get 61? So we're going to add 3 19 times to get the 20th term. You're going to add 3 19 times. Listen, don't trust formulas too much, okay? Use your common sense. If you had 20 desks in a room, right, and you wanted to move a student from the first desk to the 20th desk, you would move the 19 spaces, right? The same thing's happening here. You're adding 3 19 times. People who rely on formulas too much can sometimes not understand things, or sometimes using formulas incorrectly. If the 10th term of a sequence is 6 and the 20th term is negative 454, find the first 2 terms of the sequence. Okay, did anyone figure this out just using common sense? Anybody figure that out? What'd you get?
420 and 374.
Okay, what'd you get?
Same thing.
Same thing, okay. So how did you do it? Tim, what was your reasoning?
I just plugged in down. I figured that the 10th term was 6 and the 20th term was 454. So I just added them and got 500, but then I realized it's going down. It's negative. So you gotta add the D, or add 10 to 6 to get the first and second term.
Okay, so you're saying you figured out the first term using the 6th and 10th and 20th terms?
Yeah.
Is that what you're saying?
Yeah.
Okay. Let me see if I can follow your logic again. So, talk me through that again. What did you do?
Okay, so I added 6 and 454.
Okay, you added 6 and negative 454.
Yeah.
Okay, what'd you get?
And I got 460. And then I figured that there's 10 spaces in between the 10th and the 20th.
Okay. You said that the 10th number is positive and the 20th number is negative, so it must be dropping.
Yes.
Okay, that's common sense.
Since I want to find the first two terms, I have to be adding and going up higher rather than going negative.
So you used addition
I used
of
the
46s.
46.
Okay, how many 46s did you add to the 10th term?
9.
9. Okay, good. So all the common sense is there, and basically everything's sound and logical there. What did you do for that one?
I did the same thing that you did, except for instead of adding about 46 9 times, I just multiplied 46 by 9, then added that to 6, I think.
Yeah. Okay, so same idea.
Yeah, same like subtraction. Or I subtracted the 6 and negative 40 or 454. It's the same thing.
Right. Okay, so the general rule, guys, is this, that the nth term can be found by taking the first term plus n minus 1 times d. Right? You do not know what d is. But you can use this formula more than once. So for example, you could say the 10th term is the first term plus 5d. 9d, I mean. Said that wrong. The 10th term is the first term plus 9 common differences. And you could write the 20th term is the first term plus 19 differences. So you can write these little equations down, see? They're all true. They're just the same statement over and over again. How about the first term plus 5d is the 6th term? That's a true statement. All right. Those are all true. You don't really need that last one, though, do you? I'm just showing you can make all kinds of statements. Is it okay, listen very carefully, is it okay to say that the 20th term is the 10th term plus 9 common differences? How do you move somebody from chair 10 in a classroom to chair 20 in a classroom? How many seats are they moving? 10. Be careful here. When I move a student from the first chair to the 5th chair, that's 5 chairs back. But when I move a student from the 10th chair to the 15th chair, that's 5 spaces. Right? 15 minus 10 is 5. 6 minus 1 is 5. So you have to be a little bit careful with the counting here. But this statement is not quite true. The 10th number and the 20th number differ by 10 full spaces. Okay, so that should actually be a 10d there. So I'm just teaching you to kind of write common sense statements. Here, we're not solving anything quite yet. The 10th term is the first term plus 9 d's, whatever those are. The 20th term would be the first term plus 19 d's. The 20th term would be the 10th term plus 10 d's, technically. So you can see that the d's, the number of d's that get added, can be found by subtracting the subscripts here. So while this is an awesome formula, I think there's a better one. And nobody ever teaches this formula that I've ever seen, but here it is. Any term is any term plus n minus k d's. Now if k is 1, then that just gives us this famous formula from the book. But then that means you always need another first term. This little formula, I think, you should memorize, because this will allow you to use any term of arithmetic and find any other term of arithmetic. You don't have to know the first term. So while I like the first equation, I like the second equation, these are great, I really like this one here. The 20th chair in the room is the 10th chair in the room, plus 10 distances between the chairs. So let's use that one and see if we can figure this out pretty quickly. We said that the 20th term was negative 454. We said that the 10th term was 6. They differ by 10 common differences. Subtracting, we get the negative 460. Dividing, we get the negative 46. See? Now if you want to go back and find A1 or something, you can use one of the formulas up above. So why don't we go back, I don't know, we'll just use this one here, now that we know D, and we'll update this to read A sub 10 equals first term plus 9 common differences, but we now know that this is negative 46. And this is exactly what Tim was doing, it's exactly what Dinick is doing, but they're doing it more or less in their head. Okay, so this is where I started on this problem, put an asterisk by it. We started with the idea that the 20th term had to be the 10th term plus 10 common differences. We plugged in the numbers, and that gave us D equals negative 46. Then we went back to this statement, that the 10th term is the first term plus 9 common differences, and we plugged in the negative 46. Okay, so A1 then is, and then what's 6 plus 9 times 46? 6 plus 9 times 46, that's 420. That reminds me, we have a minimum day on April 20th, 420. Okay. $420. And the next term would be 400 and, no, you'd have to take away 46. 374, right? 374 would be A2. Okay, so A1 was 420, A2 is 374. So I guess it doesn't really matter how you do the problem, but anytime you can make a little formula for a takeaway, that'd be a great thing. So I like this one a lot. A sub n is always A sub k plus n minus k differences. All right, let's go to the next one here. Anyone think they have their answer for number 4? Anybody? Going once? Okay. What did you have, Justin? N equals 100. Okay, I actually saw that on more than one person's paper. So you want to justify that?
I put a sub 3 is equal to a sub 1 plus n minus d. So 6 is equal to 2 plus 3 minus 1d.
Okay, so you put n minus 1d here.
Yeah.
So you just kind of wrote down the formula. What's n here? You put a sub 3, so what's n? 3, okay, yeah. All right. And you put in the numbers, is that what you're saying?
Yeah.
Okay, what did this tell you? I'm getting d equals 2, what does that mean?
The terms increase by 2 each time.
Okay, good. How did you find the number of terms in the sequence?
I put, since 200 is the last term, I put 200 is equal to 2 plus n minus 1 times 2.
Yeah, so what's going on is he used a sub n equals a sub 1 plus n minus 1 times d. He used that once to figure out d. And now he's using that same formula again. This time he's using n equals 20. I mean, n equals n. He doesn't know how many terms there are. So this is the same exact formula, it's just applied with different numbers. And this time we're solving for n. Subtract 2, you get 198. Dividing by 2, you get 99. Adding, you get 100. Or however you like to solve it at the end there. Okay, so that formula works well too. I'm sorry, that method works well. You can just kind of use the a sub n formula more than once. In fact, I found I almost always need this formula not once per problem, but twice per problem. Almost always. Okay? Okay, let's switch to notes. If you feel like you need one more example of this, the last time we had a lecture was several days ago, before spring break actually. The last example of my last lecture, we never quite finished it during class. So please listen. During 6th period on that Friday, I think it was, I sat down and recorded, listen please, the last example of that note, those notes. So if you feel like you need another arithmetic there was a doozy one that we were working on. It was a tough one, and I finished it, and I put it in the video. So you can just go on YouTube and watch the last 5 minutes, whatever, and tidy up that example. Okay. I think it was period 4's version, but it's the same basic problem. Okay? All right, so we need to now talk about some other things with arithmetic sequences. Let's do that. Okay, thanks for bearing with me there. So, there is a legend that a 3rd grader was acting up in the classroom, so the teacher got upset at them and said, I want you to go in the corner and add up the numbers 1 through 100. So the teacher's logic was, this kid's going to be busy doing this for a while. The student will stop bothering my class. Okay, the problem was the student came back just a few minutes later with the answer 5,050. That was fast, the teacher said. How'd you get the answer so quickly? Did you really add 1 plus 2 plus 3 plus 4 and then so on? That's like 99 addition problems. The student said, no, I just figured it out. So does anyone know how the student figured it out? Andrew?
So you just do like 1 plus 99 and then 2 plus 98. You just do that 50 times, and you also include 50. So that's 5,050.
Okay, good. Yeah, I think what the student did was something like that. First of all, the student was clever enough to realize that he needed to write down a little bit more. Maybe a few digits at the beginning and a few digits at the end. And so what Andrew's doing is he's basically adding the 1 and the 99, the 2 with the 98, the 3 with the 97, and it creates a bunch of hundreds. They're actually 49 and a half of them. They don't quite pair up nicely. But then there's an extra 100 there you can add on. So, or you could do it this way. You could add the 1 and the 100. What does that give you? 101. And then you could add the 2 and the 99. Right, and you can add the 3 and the 98. So the student knew that there was a bunch of 101s here. He just needed to know how many 101s there were. Well, you're pairing up these numbers, and we have 100 of them. So you're putting them in pairs. How many pairs will the child have? 50. So he knew there were 50 101s here, and he just treated this as a multiplication problem. So I think the funny part of the story, if it's a true story, the funny part of the story is that the child brought the answer to the teacher, but the teacher may not have known his trick. So then the teacher had to stop class and start figuring out if the kid got it right, and then the kid's back to disrupting the class because the teacher's too busy. I made that part up. In fact, I don't even know if the legend is true, but it's an interesting story about a 3rd grader using their common sense to solve the problem. Okay, so how far can we take this logic? Can we just do this with 1 through 100, or can we do this with 1 through 600? Do you think this would have worked if the child had done numbers 1 through 600? Yeah. Okay. Do you think it would work with even numbers, 2, 4, 6, 8, 10, etc.? Do you think that would work? Okay, if you think it does, let's try it. Let's see if it works. Let's say you take 2, 4, 6, 8. Obviously, the sum is simply 20, but does the logic work that the child used? Can you take the first and last and add them together and find the number of pairs? And you can't. These two add up to 10. These two add up to 10. So that's, of course, 20. Okay, what about if it goes 2, 4, 6, 8, 10? What if they don't pair up nicely? Obviously, this adds up to 30. How would the child's logic work here? 2 plus 10 is 12. 4 plus 8 is 12. Oops, the 6 has no partner. But it's still true that 12 plus 6 is 30. But that's not what the child did, right? The child said there would be a bunch of 101s, and he predicted 50 pairs. What if a number doesn't have a partner? How did he get the 50 pairs, by the way? He knew it was 100 divided by 2, right? Can we use that logic here? Watch close. Can we just simply do what he did exactly and say, I have 2 plus 10, and then I've got a bunch of those 12s, you know. I've got a bunch of 12ers here. How many 12s do I have? Well, I've got 5 terms. I guess I've just got 2.5 pairs. Does this work? Does this give us 30? Yes, it does. Okay, so I don't know if the child knew this or not, but his little idea works on even numbers, not just, 1, 2, 3, 4. And it works when there are perfect number of pairs or not. So what we're saying is that the child could just add the first and last numbers and multiply by the number of terms divided by 2, even if they don't pair nicely. And this is how you find the sum of the first n terms of an A series, or an A sequence. What is an A sequence? An arithmetic sequence. Okay? So some people call this the S sub n formula. And please, it only works on arithmetics. So please don't use it for other types of sequence. It has to be the style of sequence we've been working with today. But it works, and it works with any sequence that's arithmetic. So you maybe never thought about this before, but the numbers 1, 2, 3, 4, 5, this is actually an arithmetic sequence, isn't it? What is the common difference? 1. What's the first term? 1. So that's actually an arithmetic sequence, and it should obey all the rules of an arithmetic sequence. Okay, so we have 2 takeaways for arithmetic sequences. One is this new rule that we created, sort of designed by a 3rd grader, we believe. And we have this formula, which helps us find any term we wish. And I told you that you don't have to use a 1 here. You can actually use a k instead. Meaning you can really treat any term as your starting term. You can treat any term as your starting term when you're trying to find, let's say, the 90th term. You can use the 70th term to do it. That's what k means. All right? Okay, so 2 takeaways. Now let's try a problem that's a little bit harder. So let's say that you're trying to design a pattern. Maybe it's some chairs in a room, and you're trying to get all the chairs laid out. And it's a stage, a curved stage like this. So you want to put your chairs so the audience can see. And you decide to go with 1, 2, 3, 4, 5, 6, 7 chairs in the first row. And you realize that you can actually fit more chairs on the next row. You can fit 9 chairs on this row. See? And in fact, you could fit 11 chairs on the next row. And you were told to make an arrangement with 10 rows. How many chairs is that? So again, this has 7 chairs, this has 9 chairs, this has 11 chairs. I would like to figure out how many chairs there would be in 10 rows. And obviously I don't want you to add 7 plus 9 plus 11 plus 13 by hand. I want you to see if you can use our new formula for this. How do you find S10? Well, it would be A1 plus A10 over, A1 times A10, A1 plus A10 times 10 over 2. That's the formula we just learned. Or some people like to put the over 2 under the, they like to do a1 plus a10 over 2. So they prefer to have the n right here, or the 2 right here, I mean, and the n kind of by itself. You could do it that way too. That is kind of a neat way to write it, because then it looks like the average of the first and last. The average of the first and last. You know, when you add two things and divide by 2, it's kind of an average idea. Okay, the only problem with this is we know that there are 7 chairs in the first row, but we don't know how many chairs there are in the last row yet. So what formula might we use to find the number of chairs in that last row? We don't have to find the number of chairs in all the rows, but we kind of need to know the number of chairs in the last row, or we can't really finish this formula. So how would we find the number of chairs in the last row? Don't we have a formula for that? What is a sub 10? It's a sub 1 plus what? 9 common differences. Okay, so what was a1 again? 7. How many chairs, or what's the difference of chairs between any two rows? 2. So how many chairs are in the last row? 25, right? So that would go here then. So I just circled my work, and I circled where I put it there, so you can see that this required a little detour step to get that value. Okay, so what's 7 plus 52? What's 7 plus 25? 32. What's 32 divided by 2? 16. And what's 16 times 10? 160. So 160 chairs, right? Okay, what would make this problem a little bit harder is if the manager of this situation told the person, hey, you've got 163 chairs. Go put them together. If there's any leftovers, put them in my office. You'd have to really think about this. You're like, well, let's see, I can do, I don't think I'm going to use all 163 chairs, you know? So that would make it a little bit harder in an honors level question. There are 3 chairs that won't get used just because adding up 7, 9, 11, etc. is always going to give us, you know, something that's not 163, you see. So just got to find the nearest number, which is 160, and then go to 3 chairs in the manager's office. That'll make it a lot harder. So, does everyone understand this problem? It's a very real life type situation, right? You probably could pack more than 11 chairs in there, but I'm just trying to show you the arithmetic case here. Okay, so that's a great practical usage of this. So today all we're just trying to cover again is how to find the number of chairs in the 10th row, you know, and the total number of chairs altogether. So that's the end. So expect to take your book home this weekend and try some 11-2 problems, including word problems about counting rows and stuff. And they're pretty creative. Sullivan and Sullivan are very creative on how they write their questions. Sometimes you find n, sometimes you find the number of chairs in the first row. So be flexible.